Welcome back to Made of Wires, where we're decompiling Castlevania Symphony of the Night. Go to soten.z.dev to learn more about that project. I'm a contributor, just like doing this with other people. And so I stream what I do, learn a lot along the way. Hopefully you learn something along the way as well. We've been working on the clock tower, and specifically we started Vandal Sword yesterday, and so I'm hoping we can finish that today. I think we're going to get right into it. So let's go over to the Vandal Sword C file. We have all the C that we wrote yesterday, all the C that you could handle. And we have one more function to finish called Entity Vandal Sword. Let's see if I have any assembly files open. Doesn't look like it's all open. A new one here. USST NZ1. This project might not be set up exactly the same way as other decompilation projects, but this is the way that it is set up. So we're decompiling multiple versions of the game. All of the assembly from the game disk gets exported to the ASM directory, followed by the version of the game, and we've just given them our own colloquial names. So this is the US PlayStation version. We just call it US. Then the path follows the directory structure of the disk, so stnz1, and then we get the splat output directory. So we're looking at non-matchings. These are functions that are not currently decompiled. We want the E Vandal Sword directory, which corresponds to E Vandal Sword C file. And then there will be a file in here called entity vandal sword.s, which corresponds to the entity vandal sword function. Hey roaming, hey Dizik. Good to have you back. Like the clouds, it looks like we're going to have some a debug section of the switch here. That's what the Charal or Charal comment at the top is from. And so we could probably import that right away when we get there. A medium-ish size function. We'll go over to decomp.me and work there. It's still verifying I'm a human. It takes a little longer. My AI is getting a little better every day. One day I'll pass that test. So we're going to start with the PlayStation version and then move on to the EU PSP version. If you don't own a copy of the game and want to participate in decompilation, the Requiem collection or the mobile games both include the PSP EU versions of the game. You can get all the files from those discs. We don't have any, and this actually might be a fun thing to do. The mobile versions are probably the easiest to extract. And it might be nice to provide a way to extract those game contents for people who have those versions. They're the cheapest versions to get. If you buy the game but don't play it, you've not accepted the terms of the game. If you do accept the terms of the game, it tells you that you can't decompile it, and so you're out of luck. We do have a bunch of function signatures. We could look at the functions that come before this, and those function signatures would be available, but the function signatures that happen after will not be available. I think I'm going to do that just preemptively, because sometimes that does affect how this is, how the decompilation works, especially if these end up being static, like Vandal Sword Draw. Alistair probably will be. So I'm going to grab those function signatures and replace them, throw them into the context so that M2C has a little bit more information. I'm also going to grab this function signature and replace the argument name. We'll call this, yeah, that's fine. Occasionally these will end up being static, and that can impact how the compiler ends up treating those files. So static functions are functions that only need visibility in that particular file, and so they can be optimized in different ways, or registers can be chosen. Okay, that's all of them. That maybe don't conflict with that other function to avoid having to push those registers to the stack beforehand. Start over, grab a new fresh decomp. Like I said, this section at the bottom, that's going to come from pad 2 debug anim, I think, or pad 2 anim debug. Let's see. I finally remember what the... So I'm going to copy all that. What the name of that file is. And that shouldn't affect anything. And let's see what else we have to do to get this to compile. So the rest of these function signatures that M2C couldn't figure out, I'm just going to get rid of all of those. And then we need to figure out what type this is down on line 114 to figure out what might be going on here. So there's the most, we don't know. So it is a pointer. So we want a pointer where the X and Y position are at approximately offset 8 and offset 10. So that could be a primitive. Let's peruse different global structs that we have and see if it looks like anything that we've seen before. This might be X0 and XY0 of the struct, or of the primitive. I don't remember offhand. And it is. So I'm going to assume that this is a primitive. So temp s2 underscore 3, we're going to make that a primitive pointer. I don't know for sure that that's what it is, but right now it fits. And if it fits, it ships. Is that appropriate? So we'll change this to X0 and Y0. And if it doesn't work out, if it's something else, then we'll switch it. This is a plus equals. I'm just going to change it to that right away. Oops. Get you back there. Okay, 125. It looks like we're getting the same thing. Let's just reuse temp s2 underscore 3. And again, I don't know for sure that this is a primitive, but we'll go with that for now. And we're actually doing pretty good. Line 35. M2C can never figure out that this is pointer addition, and it knows what the type of self is. So it can figure out the size of self, which is BC. So we're going to change that to a 1, and that should clean that up quite a bit. We have an extra 8 here going into A0. It may be related to these go-tos. Yes, it is related to the go-tos. Let's rewrite that like that, and that should Fix that. Another case with pointer arithmetic on line 55. The last 1.5. Hey, Blue Harvey. Good to have you. 62. This is probably out of order. Out of thin air. They all happen out of thin air. I'm going to come back to that. It looks like an ordering issue, but we'll see. We'll see what it is. We have a step plus. Plus, I want to go to the bottom of this switch. And if we fall all the way through, what's going to happen? So if we leave this switch, we're going to break. And if we go all the way to the bottom, we break. So instead of returning, I prefer to break as much as possible out of switches. And so I think those returns are safe to switch. I'm just cleaning things up as I see them. This one doesn't actually need to be a return. So we are going to have to create an entity extension as we go through. So the default return is unnecessary. This break is unnecessary. Let's get rid of this go-to. I think getting rid of the go-tos is probably a good next step. I know we have a few compiler warnings, but I'm not going to worry about those yet. Let's change this to an else, which means we can negate this. This is looks like a timer. And this can be a break. Okay, let's get rid of these other ones. So every time we see block 77 or 78, we're incrementing the step and then returning from the function. So that should be pretty easy to guarantee. And again, I want to make sure that, so we're incrementing, we're breaking out of this switch, and then are we breaking out of the outer one? Yes, we are. So that's fine too. Same thing here. Again, this is inverted. Kind of odd. GCC is funny sometimes. Same thing here, incrementing. 1 second. Incrementing here. All right, so we got rid of all those. And let's see if there are any other go-tos. That's all the go-tos. And so it looks like the way the assembly code is generated, it looks like there's a lot of go-tos. But that's really just the optimizer trying to reduce the total amount of code that gets generated, which reduces the amount of data that needs to be copied into memory. In some cases, those jumps might be more expensive at runtime, but maybe not. In general, the performance of MIPS is pretty well known, so a jump is going to be 2 cycles. Now I'm going through and cleaning up these additional variables that are being used for the switch that are unnecessary. Cleaning up comments that I know I'm going to get rid of anyway. Maybe some casts that are unnecessary. And some shifts that I know are going to become macros. I'm happy to talk about any of that along the way if something is confusing. And again, I'm not paying too close of attention to the differences yet. I'll get there eventually. It's odd when GCC decides to dedupe things versus when it doesn't. It's not clear to me. I thought a fun project would be to go to one of these old versions at GCC and look at the optimizer and how it works. I don't know that it's... I mean, optimally, it would be a relatively straightforward process of multiple passes of different things. It seems like it would be fun to write a bijection that could undo the optimization. That might be a fun exercise at some point. This is somewhat interesting. I'm fairly certain that this is going to be just an assignment on either side of this. But then we have the OR with 8,000. If we look at the numbers that are being assigned here, they each require one instruction to assign. They're all assigning the upper 16 bits of this register. Until we get down here, we're not assigning the lower 16 bits. And so again, I think this is an optimization. In both cases, this would have been these values, which are 0.5. So this is negative 1.5, and this is 1.5 as a fixed value. It's highly unlikely that there's an OR happening down here. I don't think it's going to be something, though, that changes the match. Cool optimization. Yeah, that's not bad. That one's not bad. Some I like more than others. Some I think are just silly. Either they're optimizations that seem like they came from a different architecture. I think that happens quite a bit. Or something else. 1 or 2/16 is 1/8, so it's 0.125. Oh, negative? Did I miss a negative? Yes, thank you. Thank you, I did miss the negative. Thank you, Dizek. And just through the cleanup, writing things like you would want them written, like your mama told you how to write C code, you get closer and closer to what the answer should be. So create entity from entity 2 is e-explosion, if I remember correctly. That should be in the context. Bottom 11 entity IDs are always the same for each stage. Oh, perfect. Thank you. All right, so now let's look at the warnings next and see what is going on with those. Oh, this is because temp s2_3 is a primitive. It's probably a good time to create our entity extension, as good a time as any. So let's do that. So like the others, I'm going to go through and get rid of all the other entity extensions except for illegal. And we'll start a new one, and we'll call this Vandal Sword. And let's look at, so at 8 words in, we need a prim, or primitive pointer. These start at offset 7C. So I need 8 words of padding. I think that's 8. And we have our primitive pointer. And optimally, what we would see now in the decompilation is that this gets chosen. And it does. So instead of rewriting those, I can steal it from M2C. And that should get rid of, actually, anywhere that we have that unsigned 32.8. We can grab that from the prim field now. And most of those other variables will probably just become the prim variable. So that's all those cases. And we should have gotten rid of both of those, yeah. So we have no warnings left. Didn't change anything for our match, but the compiler's happy. And happy wife, happy life, happy compiler. Your coworkers won't hate you. Something like that. You won't hate your future self or your past self. A few of these, I don't talk about them often, but flags, for example, I don't go and modify those anymore. Most of those, if not all of them, have linters that will replace those. The sound effects now have linters that go do that, so I don't worry about those too much anymore. See how many of these variables are gone. I'm going to replace all the primitives with the same prim variable. Roaming says, what's the difference between FLT or float to I and fixed to I? Yes, that's actually a very good question. Let me get rid of this temp S2 and I will answer that The difference is between the PlayStation SDK and Konami's own internal representation. So the PlayStation SDK for real numbers. So back in the early 90s, most computers didn't have floating point like we think about it now, the IEEE floating point. That just didn't exist as a thing on most computers. Sometimes you had a math coprocessor, and the math coprocessor might implement floating point, or a graphics card might. And an alternative to that was doing fixed point math. And for the PlayStation, fixed point math was chosen. And it wasn't necessarily clear in the early 90s if systems are going to use fixed point or floating point in the future. The advantage of fixed point is you can use all of the integer adders and other math hardware to operate on fixed point numbers, and everything just works. Whereas for floating point, you need specific hardware for doing that. The advantage to floating point is it's exponent based, and so the range of numbers that you can represent is significantly higher. The disadvantage being you can't accurately represent some decimal numbers. Is that true with fixed point as well? Can you might not be able to accurately represent like 1/10 in fixed point either. That's probably true. So it seems like mostly hardware related. Hardware versus range. What do you want? Anyway, long story short, for the PlayStation SDK, Sony chose 20 bits of integer portion. So it's the PlayStation real number format is a 32-bit value, where the top 20 bits include a sign bit and then 19 bits of integer. And the bottom 12 bits include the fractional portion of the number. And that works fine when we call like the rsine, our cosine function. They take those real numbers and then they return them as well. And the way angles are represented is based on that as well. It's radians, but in that same 2012 format. So there's really only 12 bits of precision that you get for an angle when you're calling a bunch of those functions. For working in C, however, those aren't really nice numbers to deal with. Splitting on 2012, you can use a bit field, but it's not necessarily optimal. So all of the Konami code uses 1616 real numbers, where 16 bits is used for the integer portion and 16 bits is used for the fractional portion. And then you can probably, like we have done, is use a union with a 32-bit value and then a struct with two 16-bit values, where you can access the high and low portions of that as a 16-bit value very easily. So when you see, I don't know where the FLT designation came back. I call it a PlayStation format real number. Somebody who came before me on the Symphony of the Night decompilation project decided to call it FLT for float, even though it's not a float. Just a different type of real number. And so we see some of those things here, like this. This is a little strange. So as a PlayStation format number being passed in here, this is actually times 50. Go down and look at that, make sure that I'm getting those numbers right. Yeah, that turned out right. And so the important thing to remember when doing that is, if it's a PlayStation SDK function, it's going to use that 2012 format. And if it's a Konami function, it's going to use the 1616 format. So we have an Unsigned 16 that's 10 shorts into the entity extension. Let's name that one next. I'm just going to call it angle. So we have 2, 4, 6, 8, 10. So I think it's here. And then we'll need another one. Uh, 20 bytes, yes. 1, 2, 3, 4, 5 words is 20 bytes. That's correct. Right? I think that's right. So where was I? Up there. That hex 400. Is being applied to the angle. I see. So when we looked at it before, basically this approach target, we have some rotation that we're currently at, which is self-rotation. We have the angle that we want to be at, and then the increment that we're trying to get to. And the direction is chosen by whether we're facing left or not. I'm trying to figure out whether... Let's do this in 2 steps. Okay, so that did the right thing. That would be less instructions than the other one. So let's replace all of these. Get rid of our player placeholder. That probably would have been good to do early on. Let's look up here and see what other ones we have. I should have like a set of regular expressions that I apply at the beginning to fix all those up. So now I'm just going through and trying to find superfluous variables and if we can get rid of them. Let's do this one next. This this other unsigned 16 that's 1, and I'm going to call this timer. All the times that it's being used, it's either being set or it's being decremented and checked against 0, and that's a pretty common pattern. So that's going to be right here. Is it going to be signed or unsigned? I don't know. I'm going to make it signed, and then we'll see if that's correct or not. And so in most of these cases, what I want is an implicit check for 0 after a pre-decrement. And let's look at 122 and just see. Yeah, so that all looks fine. So I'm going to find those other cases, and it's probably worth just copying that whole expression. And that's going to get rid of a lot of extra variables as well. That looks good. Let's go through and clean up variables. That's what we'll call prim index. Sometimes that ends up being assigned 32. We'll see. We have another timer. So I'll just call it timer 2. And it's the other side of this angle. The angle was 10 shorts in, and this one is 11 shorts in. And we're going to do the same thing where it'll be a pre-decrement. The extra shift that happens there is just part of GCC trying to treat the 16-bit value as cheaply as a 32-bit value as it can. I'm going to do the same thing. Oh, weird that worked out to be the same already, but okay. I'll take it. This looks like a velocity x minus equals velocity x divided by 6 divided by 32. Let's watch the instructions as we change that. It actually compiled to exactly the right thing. And I said 32, and then I wrote 16. And that compiles to exactly the right thing as well. I'm going to assume that this is a plus equals and then a check. I'm not going to worry about, I guess we're right here anyway, so I will worry about whether it matches or not. It just feels righter to me, and it is righter. Not really any closer, though. Is this the same thing? Oh, okay. So this is another fun GCC optimization. So I think that this is saying facing left and velocity x is greater or equal to 0. I will watch the instructions as I change that. They're wrong anyway. So what happened was GCC decided to do the less than check and use the result of that as what to assign instead of wasting a register or wasting an instruction on setting an immediate value, which is kind of funny. I'm going to try that. We'll see if this is correct. It's not quite that. So my brain is not. So if velocity is less than 1, and facing left is not true, let's make a truth table. One second. Oh, there's an else here. how gross. How gross. Okay, so so if facing left and something like this. That's not quite right. My brain's hurting. So we'll go to the PSP for that. It's something along these lines, though, where so if we're not facing left and velocity is less than 0, then we're still not going to be facing left. If we are facing left, but we're still going to rotate, so there must be an else here. Yeah, roaming, I think you're right. I think there is an else if. So I'm still gonna use the PSP version. I agree that there is an else if. That can't be quite it. What is the other side of this? Other side would be greater or equal to 1? No? Yeah. I mean, again, I think grabbing the PS. Let's try this. Otherwise, I don't want to spend too much time on it. No, we got it. Is velocity signed? Yes, velocity is signed. It's kind of odd though. Less than 0. I'm going to say that this is actually probably less than equal to 0, and this is greater than 0. Not that that's going to change the logic at all. And maybe it's inverted. We could try inverting it. Because so velocity x is one of those Konami fixed point numbers. And so 1 is the smallest fractional value that you can have there. It's not really relevant. So it probably is based around 0. We'll come back to it on the PSP side. We're actually worse off than we were before. We got rid of a variable that likely wasn't being used. So we'll come back and we'll get it. And it could be, I could spend some time and think a little harder about it. Definitely a GCC optimization that is not good for humans. And is that really our only other issue here? Looks like maybe a type issue. Forget normalized angle. Angle here, it looks like maybe should be a sine 32. And by looks like sine 32, I mean no, definitely not a sine 32. What is being shifted? V0. That's going into arg A2, which is the result of this atan function. So atan is being treated as a sine 16. So either get normalized angle function signature is available, or it's being cast. And again, we'll try to figure that out. It looks like it might. It's not in my context, but it does take all sine 16s, and it's in ST common, which would be available. So we'll throw it in the context. And then I can get rid of that cast. Except it made everything much worse. Weird. So I'm going to put my cast back. We should be aware of that in case we see some issues with it later. It is used several places with the function signature available. 118. So ordering of these variables, that may indicate that these args are being pulled out as variables beforehand, calculated and then passed in. We would need pos x and pos y values. The atan declaration is less likely because it's part of the PlayStation SDK, and usually those functions are not visible. The declarations are not visible. So I'm not convinced about that. Move entity. This is a phantom argument. It's just a value that was in the A0 register. And so M2C doesn't know that it's not an argument. That's kind of an interesting design decision for MIPS, though, or at least part of the ABI. Registers typically are not cleared. So it is completely possible to read registers from a function for data that you're not supposed to be able to see. All right, let's leave it at that for the PlayStation version, and then we'll take it home with the PSP version. I'm going to rename this. So a little bit of prep that will be necessary. Still a human. Still pretending to be one, at least. There are a few things that I'm going to need in the context. Some of them I think I want, like define explosion 2. That's safe. The other ones, when you modify the context from this screen, whatever you change ends up being in all future contexts, whereas if you change it once the scratch is created, it's local to that scratch. So I don't want to put those in quite yet, but I will now. Oh, and I got rid of my explosion. So I have my function declarations that I think will be there. I'm going to grab the entity extension, grab the whole thing. And then we are working with primitives. So just to be safe, I'm going to update primitive. And then we will see how close we are. Oh. Why are we so far? I don't have the right preset. That's much better. So we're missing some variables. So like I said, I thought the pos x and pos y might be there. That could be it. Let's go down and look at that. So that's down here on 118. What we should see is the subtractions of these two fields. They should go into S registers. And if we see that, then it's pretty likely that there's something there. There's actually something that I didn't expect, though. We're taking the entity's address and putting it in a register, and then using that entity's address to get everything out. And then are we putting those values into a register, S4 and S3, and then using S4 and S3 as our arguments to ATAN? That is exactly what's happening. So we're taking a reference to player. I'm going to have to create pos x and pos y. And by pos x and pos y, I obviously meant the opposite. All right, and let's go create those. I reused the existing entity pointer because I think that's more likely than having a separate player variable. And let's go back to 118 then and see how that looks. It would help if I use the pointer that I just created. And that all looks good then. Okay. And how is our stack looking? Stack's looking good. We have this. Oh no, we don't. So we have another field 8 bytes in that we need. And what is it? It's some kind of Boolean. Like, we could call it like is dead, because if it's true, we're just it's not quite as dead. Just gonna call it flag for now. So that's 8 bytes in. So we have our value here. Flag, I know it's very original. And we're gonna just use a 32-bit type set to 24 bits in width. Oh, I was 1 off. It's 10 in 4, 8. So we need another 16 bits of padding. And so this is at 86. And then our flag. And then at 87. We have another 8 bits of padding. And all that to get rid of the mask. Oh, what happened? An extra colon, that's what happened. And when they're Booleans like that, I like using true and false. So the bool type in C is, the width of it is not defined. Within this code, I'm not sure if it's within all PlayStation code, but within this code specifically, the bool flag, or bools are usually unsigned chars or unsigned 8-bit values. This self +1 is done outside and assigned to a variable. A bunch of ordering issues here. And again, setting a specific variable first and then using that variable. Here we have a constant 43. That is going to be another entity ID. And at one point I had the stage init file open, but I don't think I do. Vandal Sword hitbox. So we do have a global for that, but it's global's not being used. So here, the sign extension, so the allocate primitives API, we do have a signature for that. That returns a sign 16, but like I said, it's usually not a sign 16. In code, it's usually a sign 32, and that is the case here as well. Looks like ordering issues again. So we need, what's that offset? 34. Need that right after. There we go. 53. S0. It looks like I'm sorry. A0 is getting no, S0 is being assigned offset 0. It almost looks like prim equals prim next is happening again. Yeah, so that isn't used, and GCC knew that, and so it considers it dead code. There's an extra move happening here, which may mean probably means we have a an assignment like this that's incorrect, or a comparison wrong somewhere. My guess is it's related to that equals 0 facing left thing that was an issue before. We'll come back and try to find that. That's one of the weirder MetroWorks compiler quirks. When you have comparison operators that are wrong, register allocations change considerably. Here we're grabbing the player pointer again. '87. Roll should be, it looks like a sign 6. Unsigned 60. Not that unsigned. So it does look like sign 16. And then maybe a manual mask. Or a cast. It already is signed 16. So we're getting a mask of 7FFF. And if I... Which is... oh, that worked that time. I don't know why it wasn't working before. So that's... We should have Essent Max. I'm pretty sure that's in either types.h in 16 max. Uh, 88 again, how those registers are assigned, I think we'll have to do with that comparison when we get to it. Here we're now at this this other artan, and so we have pos x and pos y variables. I think that those are getting set again, so let's do that. And use those variables. So that's a little closer. We're missing a sign extend and a assignment to S1. Going to R2. So let's try. What do we want to do? So I am going to try adding this again. Void. A bunch of these were unsigned 16s, but it looks like at least that last one is a signed 16. Oops. Jumping around. Let's try signed 16. I don't remember what it was. Let's look at M2C and what it came up with. Yeah, so that's a different signature than what we currently have, where it's used otherwise. And it does think that this was done inline. It actually thinks the whole thing was done inline. Okay, I'm not quite sure, but I'm going to keep going, and we'll come back to that one. the result of the ATAN call is assigned to register S1, which is then used as argument A2. So this is likely is getting moved into a register. So I'm actually going to call that, it looks like it's angle still. And then so we have an extra move in there. Not concerned about that. And I'm not concerned about this A to A1. So I think this is correct. And we did it without the function signature, which I think is most likely. 105, there's an extra mask. All right, now we're getting into that 148 section. And let's see what M2... Oh, I closed it. Let's see what M2C came up with. Which one is this? So we're at case 5. Oh my goodness, it is a variable. What kind of madness? So this is relatively unexpected. And what type is var S5? So it looks like just an integer. Do we have an extra integer? This may be reused elsewhere, but kind of an unexpected plot twist. So we are saying if velocity is greater than 0, forward velocity equals true. What I called it? Yeah. No. If it's greater than 0, forward velocity is false. I need to rename it to backward velocity, and I lost my place. We'll keep it as true for now. Make it extra confusing. And we could possibly just set this to the result of this expression, except it's inverted. So then if we're facing left and... No, sorry. If facing left does not equal forward velocity, we're going to set it. And then negate. And this... Yeah, I was convinced that it was a optimization on it else either. So this is some clever developer optimizing. And... screwed something up along the way, so let's figure out what that is. And go back down to 148 and see how close it is. So it tells us if we have 1 assignment or 2 assignments. basically is this. We have a move of 0 into S3, or we have a load immediate into S3 of 1. This could be written as load immediate S3 0 as well. There is a 0 register though, so the move instruction probably is faster than reading the value from the instruction. And by faster, I mean, I don't know, uses less stuff. But that looks like it. Weird. That's weird. So I added a variable which increased our stack space by doing that. And so we need to figure out what that is. And actually, it's var s5. Let's see if var s5 is used elsewhere. It was used for the entity, so it isn't used elsewhere, so it is its own thing. But it looks like I have too many variables now. Before I had too few, and now I have too many. So we have to go variable hunting. All right, let's do that. Let's see if anything is... So like angle and roll, those may be the same thing. Let's start there. Because roll ultimately is used as an angle. So on line 88. That's register S1. And so what we want to see is angle. And on line 100, is that also S1? And it is. So roll is not its own thing. I think that hopefully gets us to the right place in the stack. And based on the match, I'm guessing our stack is correct. And it looks like it is. So some variable ordering looks wrong. And the register allocation isn't quite right. But the way we're using them is correct. So probably just moving down, reordering something. And that was it. So the negative velocity variable just needed to be higher. And now everything matches. There's a button difference down here. That's just a platform difference that'll be taken care of by macros. Symbols. Roaming called out that could the return on 37 be a break? Possibly. I keep it as a return though. And the reason is because this is the exceptional case where we can't allocate a primitive. And this makes it obvious that this is like degraded logic. And so would a break work as well? Yeah, that it would be fine and it would do the same thing, but I want to make it kind of super obvious that that's an exceptional case. So using the return is more akin to like throwing an exception or something like that there. I'm going to make this an and, see if that still works. And that seemed to work fine. We made a few changes. Do I have any illegals left? Nope. Made a few changes to the entity extension. I'm going to copy those over to the PlayStation. And I think I already put we have one more entity ID declaration. And the rest, oh, this is probably an init, yeah. And it should work. 380 is a little high. This may all be symbol differences. That's a little higher than I would expect. So 89, this is where I manually added a mask, I think. And it looks like it's possibly something else. So oh, the cast or the assignment works. Let's try it again over here. 89, 88. Oh, we actually have a macro specifically for this. Rand, where is it? It's common. Game. Yeah, PSP Rand mask. So many strange quirks like that you just have to have experience, I think, to remember them all, or write the if-def yourself and then learn about it in a code review. That solved that last part, so everything else looks fine. So let's get it working. Of course. Why didn't it work for... Let me build this again. Looks like I screwed something up. I need to add the entity extension. Thank you, thank you. Well, my clock tower clouds are still in line. I need to fix that. Now we'll get another one. So this will take a while. Can you imagine all this compiling on a 25 megahertz 486 in Windows 3.1? Maybe if you were lucky, you had a Windows 95, maybe 486-100. 95, would there have been 100 megahertz 486? Sorry, looking up when a 100 megahertz. We either had a 25 megahertz or a 33 megahertz around that time. Oh, but Pentium already existed. So you could have had a Pentium, and Pentiums, I'm pretty sure, we're at 100 megahertz out of the gate. Okay, so if you were a Konami developer, you could have had something a little faster. Still not as fast as this. All right, so I have my entity extension, and now I can try again. I was happy to have anything. When I went from, I think we went from, right? Am I in the wrong? I'm in the PSP file, that's fine. Too many files open. All right, so this worked fine on the PlayStation. We're going to run into the same issue here on the PSP that we had with clouds. It's unlikely that the data segment is mapped correctly. So let's figure that out. We have a little bit of data, and we have that string that we need to take care of. So we're going to go to the splat config. Look for Vandal Sword. We have some RO data, which is good, but we don't have any data. And so Vandal Sword happens between Skull Lord, Create Entity, E-Life Up. So let's look at data. So it's going to be in this first section. That's 24A. And so we'll have the Charal. This is likely the Charal from Vandal Sword. But we have that other global data too, which is this C08. Sorry, C080. So Vandal Sword does start right at 24A0. And it's going to go through at least the Charal string. And let's look for this B0, see if that's in there. It's not. Let's see where that is. So that's part of Skull Lord. So we go through 24A30. I'll go right to dot data. And we'll close this, and then we'll see if we can do this one too. Drat. I need both. I need that other data too. We will try to do it all together though. So we'll grab that. And we'll grab the other data. Did I open? All right, so our other data are C080 was of this type. So 2 bytes followed by 4 shorts. We don't M2C wasn't able to figure this out. I'm going to take the little endian version of this, and we're going to work with that. We'll see how close we can get. So we're going to make this static. Make some room. And use the wrong paste buffer. So we need start a new struct, grab the first byte, grab the second byte, flip the bytes for the first 16-bit value. And then how many more do we need? 1, 2, 3 more. So this will be our end right there. And so all of these we need to flip as well. And I could write a regular expression to do this, but there's so little of this that I'll just do it by hand. So we have 2 bytes, 4 shorts. I know the 3F here I didn't add with zeros, but I'll do it. This one, interestingly, is reversed. So here's our second, 1, 2, 3, 5, 6, and then some padding. And I could do this with columns. And don't forget my commas. That happens to me frequently. I'll forget commas, and then the compiler doesn't complain about it. And in the worst case, maybe I transcribed this incorrectly. The diff stage utility should make it pretty obvious. Yes, the FFF ones are negative values. So we'd have -1 8 here, which is 24. -1 4, -5 is going to be -11 or -10. I don't know. We'll find out. Now they're definitely going to be wrong. E and 16, and we can get rid of the extra zeros. And I probably screwed one or more of those up, but we'll see. Oh my goodness. I screwed none of them up. Fantastic. So we got that working. But that means we also have a couple things we can do now, which is nice. I have this open in the second editor. Not eClouds, eVandal Sword, that's what I wanted. So now we can use this over here as well. We can change, I'm going to actually undo that for a second. We can change the symbol name because it's static to match the PlayStation, and then we don't need the other symbol name anymore. And now we need to find where that data is for the US version as well. And that's a little easier. The offsets are not as strange. Cloak Knight, Sword Lord, Phantom Skull. It's going to be right about here. Okay, so we're looking for the B8 in the data by itself, B8C037, so it looks like right here, 2144. And it's going to go to the end. So nothing more that we need to do. Two 114. And that worked as well. So now we have the PlayStation file and the PSP file that are effectively the same. So we can take away the PSP file, Vandal Sword, get rid of the PSP specific directory. And it should be clean, and it is. So another one done, and another one matching. Not too much. Oh, look at all the variables that I didn't clean up earlier. I'll have to go back and clean all those up. But it looks like Vandal Sword is done. So another enemy type is finished. Oh, wrong button. Appreciate everybody stopping by. Physic and roaming. Oh, JB, missed you. Thanks for stopping by. And go to soten.z.dev to learn more, and we'll be back next week. Adios.